Uh, dear students, I am AMK. Welcome to the Concept Classes Mati. I am going to discuss a topic from electricity of class 10. An expression for the equivalent resistance of a circuit when the resistors are connected in series. Okay, which is very much important. Using Ohm's law, I need to find out the equivalent resistance of the circuit using Ohm's law. Okay, this is very much important, and I am going to discuss with the help of an example also. I will discuss an example to understand, to clear your concept about that topic also. The topic is from class 10th, right? uh, equivalent resistance equivalent equivalent resistance in series combination in series combination for this I am going to consider three resistors R1, R2 and R3. Before that, what is series combination? We need to understand what is series combination. Clearly, when three or two or more resistors are connected end to end, then it is called series combination. Suppose say three resistors, R1 resistors, here is another resistors, R2 resistors, and here is another resistors, R3. Look Look at the combination, look at the pattern of the combination. R1 is connected end to end to the R2 and R2 is connected end to end to the R3, and this is called series combination. Okay, and this pattern is called series combination. The equivalent resistance, total resistance of this combination is Rs. S is for series. S is used to represent series. R1 plus R2 plus R3. This is total resistance. Clear? Now I am going to find out the expression for this combination. The students, here I am going to consider three resistors R1, R2 and R3, and the potential difference between these three resistors is V. Clear? And the current R1, R2 and R3, and the amount of current passed throughout three resistors R1, R2 and R3 is said to be I. The amount of current is passed throughout these resistances is supposed to be I. Clear? Now potential difference, suppose say potential difference between the resistors R1, this is the resistance is R1, that is V1, and between the two ends of the resistance R2 is V2, and the two ends of the resistance R3 is C3. Okay. Students, why it is important? Last few years, or more than 5 years, the expression for series or series or parallel combination has not set by the CBSE. So I think this year this question will be crucial. This question will be asked in different manner. Okay. So try to understand and try to go into the depth. See, the total resistance supposed to be RS. Total resistance or equivalent resistance of R1, R2 and R3 is RS. Okay. And another thing, the potential difference of the whole circuit is V. V is equal to the V1 plus V2 plus V3. It is 1. The potential difference here is equal to the sum of these three V1, V2, V3. That is V1 plus V2 plus V3 is equal to V. Okay. Now, if the equivalent resistance of the circuit is Rs, then using Ohm's law, V is equal to IRS. V is equal to IRS. Here, now it is equation number 2. Students, I am going to apply Ohm's law. Here, R1, R2 and R3 resistances separately. What will happen? Let's see. In resistance R1, using Ohm's law separately in R1, R2 and R3, we get V1 is equal to I R1. Similarly, in R2 and R3, I will have V2 is equal to I R2 and V3 is equal to I R3. Now total potential difference are between the ends of R1, R2 and R3 resistance will be adding these V1 plus V2 plus V3 is equal to IR1 plus IR2 plus IR3. Again, V1 plus V2 plus V3 is equal to what? V. V1 plus V2 plus V3 is equal to V. I whole R1 plus R2 plus R3. V is equal to what? IRS. IRS is equal to I whole into R1 plus R2 plus R3. From here, students, I will be eliminated and the equivalent resistance of the circuit will be Rs is equal to R1 plus R2 plus R3. This is the expression for the equivalent resistance. This is the expression for the equivalent resistance of this circuit. The total resistance of the circuit is given by Rs is equal to R1 plus R2 plus R3. You can calculate equivalent resistance current and potential difference between the resistor by using this formula or Ohm's law, applying Ohm's law. I hope this expression will help you, and most importantly, it is very important. I repeat, it is very important for this year. So I hope you will take it seriously and go through this proof. Yeah. Now I am going to elaborate this with the help of an example. I will take an example from a competitive exam book. I will take a circuit. Okay. I will take a circuit. Calculate the equivalent resistance and total current in the circuit. Okay. The circuit is here. Circuit is given. I will try to draw the circuit. It is 30 ohm. This is 6 ohm, and it is 3 ohm, and it is 8 ohm. A. This terminal is C. It is D, and it is B, and it is E. Now I have to calculate. The equivalent resistance of the circuit and the amount of current passed throughout the circuit. See, look and observe closely. These two resistors, 3 ohm and 6 ohm resistors, are connected in parallel combination, and 8 ohm resistors is connected to this parallel combination as series. Okay, and then the total resistance of this combination will be connected to 30 ohm resistance in parallel combination. Therefore, I will have to find out the equivalent resistance of these two resistors. First, solution equivalent resistance between 3 ohm and 6 ohm. That is, in parallel combination, when two resistors is connected in parallel combination, then equivalent resistance can be calculated by Rp is equal to R1 into R2 by R1 plus R2. R1 is equal to, suppose, 3 ohm into 6 ohm by 3 plus 6 is equal to 6 into 3. 18 by 9 is equal to 2 ohm. The equivalent resistance between these two resistors is 2 ohm. Now this 2 ohm resistance is connected with 8 ohm in series. Again equivalent resistance between C and D. This is in series. Rs is equal to Rp plus 8 ohm. Rp is equal to what? 2 ohm. 2 ohm plus 8 ohm is equal to 10 ohm. And now 10 ohm resistance, the equivalent resistance of this combination, that is 10 ohm. 10 ohm resistance will be connected in parallel with 30 ohm resistance. Now I need to find out the equivalent resistance between 10 ohm and 30 ohm using parallel combination. Again total resistance of the circuit is R dash T is equal to 10 ohm into 30 by 10 plus 30 is equal to 10 into 30 is 300 divided by 40 is equal to 30 by 4 is equal to 7.5 ohm. Now students, the total resistance of this combination of the circuit is 7.5 ohm. Now I am going to use this resistance to obtain the current which is flowing throughout this circuit. Clear? Again, by using Ohm's law, using Ohm's law, V is equal to I R dash P. Potential difference is given, that is 15 volt is equal to I into R dash P is equal to 7.5 ohm. Then I is equal to 15 by 7.5 is equal to, implies I is equal to 150 by 75. Okay. Now I is equal to 150 by 75 is equal to 2 ampere. That is the amount of current that which is passed throughout the circuit is 2 ampere. This is the solution of this expression. This is the solution of this uh, problem, circuit problem, which is from electric current, chapter electric current. And I you all will solve this type of question, this type of numericals at home, and practice more and more this type of numericals at home. Okay. Have a good day.